Hi, YouTube. Although, to be honest, this one is probably going to go up on TikTok too, so hi, TikTok. Um, I wanted to make a statement about what happened at Amazon in October of 2025 and the whole incident that happened with the outage just the other day with the East servers. When Amazon frames the October 2025 DynamoDB outage as a DNS hiccup, let's be honest, it wasn't. What the incident exposed, whether AWS is willing to admit it or not, is that their own architecture is not aligned with the same best practices that all engineers are told to follow. A single point of failure was at the core of this incident. DynamoDB's API is US East 1 relied on a regional DNS dependency. When that endpoint failed, customers had no way to fail over. This was a classic SPOF, which stands for single point of failure, and it sat at the heart of Amazon's cloud backbone. We are told to eliminate SPOFs. Amazon carried one inside the black box until that black box cracked under real world load. You know, regional issue, global blast radius. Though the root cause was scoped to US East 1, their effects cascaded worldwide. Control plane and service interdependencies meant that apps in other regions broke too. This shows hidden coupling. Even if you think you've engineered multi-region, the vendor's control plane can silently tether you back to a single hub. You know, customers were left without an escape hatch. Best practices say it designed graceful degradation, queue rights, catch reads, and diversified providers. But when the vendor itself locks you into a single proprietary API, you inherit their design flaw. Customers had no alternative endpoint, no fallback, no way to self-heal. This outage shows that vendor lock-in magnifies fragility. The fact is that the downplaying of the incident also hurts more than the failing. AWS's initial communication emphasized mitigation and regional DNS issue, but to anyone affected, it wasn't minor. Minimizing impact symbolizes mismanagement between AWS's leadership and engineering reality. True credibility comes from transparent RCAs, visible architecture changes and clear apologies, and not spin like this. Cloud is not what we've learned. Cloud is not magic. If you can't see inside, assume single points of failure exist until proven otherwise. Multi-region isn't enough. You must validate failover yourself, not trusting marketing diagrams. Quote, lock-in has a cost. The more you lean on proprietary features, the more you inherit the vendor's weakest link. Honesty matters. An outage can build trust if handled with humility. Pretending it's a blip erodes it further. Closing thoughts. Investors know not to put all their money in one basket. Engineers know not to put all their systems' fate in one vendor's endpoint. The DynamoDB outage wasn't just downtime. It was the curtain pulled back, showing that even the giants break their own rules, which is not a good look. Amazon should be groveling. They should be acting with great humility. In this one, its apology should be significant for what just happened. The fact is that they should be engineering into the cloud fault tolerant systems. I would like to point you to the TCP, you know, protocol at its core, which degrades gracefully, as ChatGPT mentioned. When TCP can't, when one route fails, to route packets, it simply reroutes and finds a different packet route to route traffic through. But when the modern, but what was revealed here about DynamoDB is that it was not at all, consistent with best practices, and fault tolerance is not as deeply woven into that black box as you would hope for a cloud service provider. So, you know, that I think that this was more than a minor incident and a minor hiccup. I mean, I don't think that there's a developer or engineer in the world who believes that not building fault tolerance into your systems is best practice or a good idea. There's not a single person who works in DevOps who thinks this is a good idea. There's not a single person who I know of in the IT industry that thinks this way. I mean, the common party line is that redundancy is survival. Having systems in place because, really, if you think about it and you think about what's been going on in the web for years and years and years, the fact that one server may be down, for a while is pretty much routine in nature. Outages are to be expected, so to speak. I mean, systems fail with such extreme frequency that really, when it comes to IT, we should be engineering in our systems with this in mind about, the fact that you can expect a certain number of systems to, fail on a routine basis. Now, that this is just the reality of things, and so, what you do in a situation like that is that you engineer systems so that, you can, if one thing fails, it just tries something else automatically. It goes to it. Backups upon backups upon backups. It has a diversity of options it can try instead. If that first one fails, and then it goes to another, and if that one fails, it goes to another, and it cascades like a house of dominoes in such a way where it just keeps retrying. So it's like inverse dominoes, the complete opposite in reverse. If one doesn't work, it tries another until something finally works, and things will only fail if all of those points that things are relying on fail at once, and what Amazon was revealed is that we've built in a lot of fragility to our systems that really shouldn't be there in the first place, that really need to be systematically rooted out and eliminated. And I don't mean this in the sense of people being eliminated or anything. I mean this in the sense of like software vulnerabilities need to be hunted down and eliminated. Systems need to be upgraded to engineer in reliability and fault tolerance into them, and robustness and graceful degradation like that. I mean, yeah, sure. If there's an outage, like for instance, you could engineer systems in where, like, if one server goes down, things are going to be slower. For instance, because what the alternative routes aren't necessarily as fast, but at the same time, at least the internet hasn't gone down. And the thing that grips me about it is that there are ways to write software so that this is what happens. If it can't get through to one DNS server, it just tries another. So that it's engineering in, fallback options in case one of the DNS servers happens to crash and go offline for a period of time. It will simply try a different one. And yet this is not what transpired, as we know, at Amazon. Like, it revealed behind the curtain of that black box that there isn't this sort of fault tolerance in their systems, which is out of alignment with best practices, which should be concerning to you. And the fact that they tried to minimize the incident in light of it as well, and tried to pretend that it was a minor hiccup, is also concerning as well. This is not a hiccup. This was a major fuck up on their part, and they should be groveling. What they should be doing instead is, like, here's a suggested, letter that was, a statement that they should have made instead, and this is a mock statement that they should have made that I had generated for me in ChatGPT. But I'm not a quote vibe coder. I'm learning, at the same time as taking suggestions from ChatGPT about how to improve things. So, mock AWS statement on the October 2025 outage to our customers, partner, and the broader community. On October 20th, 2025, a failure in the DNS resolution of our DynamoDB API endpoint in US East 1 caused widespread service disruption This outage lasted for over 13 hours and impacted customers globally, including those who did not directly use DynamoDB. We want to be clear, this was not a minor hiccup. It was a major systematic failure that fell short of the reliability and resilience that you expect from AWS and that we expect from ourselves as well. What went wrong? We relied on a single regional DNS endpoint for DynamoDB. When that endpoint failed, the customers had no fallback paths. Dependency between DynamoDB, DNS, and global control planes meant that the blast radius extended far beyond a single region. Our architecture did not align with best practices that we ask our customers to follow, avoid singular points of failure, provide redundancy, and ensure graceful degradation. Our responsibility, this was not your fault, it was ours. Many of you build critical systems on AWS and you trust us to deliver on October 20th. We broke that trust. For that, we are deeply sorry. What we will change, multi-region resilience for DynamoDB endpoints. By default, client connections will be able to fail over to alternative healthy regions automatically. Decoupling of control planes. We will eliminate single region dependencies and global service management. Customer visible failover guidance. We will publish clear rule books and providing tooling so that you can test failover scenarios yourself. Transparency. Within 30 days, we will release a post-event summary PES, including root cause, contributing factors, and the architectural changes that have been mentioned already. We know our apologies are meaningless without change. These changes will be measurable, testable, and visible to you. Closing. Your systems depend on us, and you should never have to wonder if AWS itself is a single point of failure. We accept full responsibility for this outrage and commit to doing better. Sincerely, Amazon Web Services. Now that would have been a much better way to handle this incident than what they have done. Instead, what we have received is a desperate attempt to minimize and to pretend, that this was just sort of a DNS hookup. That's not going to cut it here. I'm sorry, we're too smart for that. They look. I mean, is there? Can you? Redundancy is survival. The fact everybody knows this. I mean, it's so much so. Like if I mention that one of my strategies, because of the fact that I'm a player that is a little bit more cavalier about risky software and everything, is to have robust backups. They'll tell me, okay, cool, so, make a backup of your system, sync it to the cloud, put it on multiple cloud services, have it on, multiple clouds, at the same time concurrently, so that, if one fails, you've got on a different cloud, and you diversify the risk and spread it around, and this would be considered best practices to have a backup. I mean, I have a piece of software called Acronis True Image that I use to back up my systems such that I can rapidly redeploy my operating system in a known clean slate very quickly if something does go wrong, so that in the case of being hacked, I can when I format my system, when I quote unquote format my systems, I don't have to reinstall all the software packages that I have on my system and reconfigure them the way that I like. Every single time I have to go through a reset of my systems and core systems, because I'm not able to drill into them and find where the hackers have bore into my system and hid their malicious code and everything. I don't know where they've hidden it at that point. If that happens to me, so I can rapidly redeploy in a state of back to a known good state and everything, and they'll tell me to distribute those backups across multiple services, so that I have robustness in this. Like if I can't get through to one site, I can get through to it on another, and rapidly redeploy my systems that way, so that I don't. Yeah, like you get what I'm saying. There's a saying in the IT industry, that 1 is none, and 2 is 1, and 3 is 2, and basically n minus 1 to anything that you have in terms of backups, because you can usually count on at least one of them to fail. This happens on such a routine, with such frequency, that if you don't have backups, you're almost certainly going to you know, lose the system that you've got on hand. You know.